Hey everyone, and welcome. Today we're going to pull back the curtain and go on a pretty wild ride. We're going to follow the secret journey your Python code takes from the moment you hit run to the second it actually does something.
We all do it 1,000 times. We type python myscript.py, hit enter, and poof, magic happens. But what is that magic, really? You might think, oh, it's simple. Python's an interpreted language, so it just reads the code line by line and runs it. But what if I told you that's not even half the story? That it's actually way, way cooler than that?
Yeah, see, that whole interpreted label, it's a massive oversimplification. Before your code ever gets executed, it goes on this incredible multi-stage journey, a full-on transformation that turns the code you write into something the Python engine can actually understand and work with.
To really get this, we need a hero for our story. And our hero is going to be this super simple, humble line of code, x equals 2 plus 3. We're going to follow this little guy through its entire life cycle, from just being plain text all the way to a final result.
Okay, so here's the roadmap of that journey. It all starts with your source code, of course. From there, it goes through a few key stages, something called lexing, then parsing into what's known as an AST, then it gets compiled to bytecode, and only then does it finally get executed. Let's break it down step by step.
First up, lexing. You might also hear this called tokenization. This is basically the very first step where Python looks at the raw text of your code and starts breaking it down into the smallest possible pieces that have some meaning. The absolute best way to think about this is to imagine you just dumped a giant tub of Legos all over the floor. Right now, it's just a messy pile. Before you can even think about building that cool spaceship, you've got to sort through the pile and identify the pieces, right? This is a red 2x4, that's a blue single stud, here's a clear window piece. That's exactly what lexing does for your code.
So for our little hero, x equals 2 plus 3, the lexer scans it and pulls out 5 distinct bricks, or tokens. It says, okay, I see a name, and its value is x. Then I see an equals operator, then a number, which is 2, then a plus operator, and finally another number, 3. Now here's the key. At this point, Python has zero clue what this line means. It just knows what the individual parts are.
All right, so we've got our pile of sorted Lego bricks. Now what? Well, now it's time to actually start building. This next phase is all about understanding the structure, the logic of your code by building something called an abstract syntax tree, or as you'll hear it called, an AST. So what on earth is an AST? You can think of it as the architectural blueprint for your code. It's this cool tree-like structure that organizes all those tokens and shows the relationships between them. It's not about the text anymore, it's all about the intent. For our code, the blueprint basically says the main goal here is to perform an assignment, and the value we're assigning is going to come from adding two numbers together. And this is exactly what that blueprint looks like. You can see it right here. The top level, the main goal is an assign operation. Okay, what's it assigning to? The target is x, and what's the value? Well, the value is the result of a binary operation. The operation itself is addition with a left side of 2 and a right side of 3. See? We've officially gone from a random pile of bricks to a structured model of what we actually want to build.
Okay, so we have a solid blueprint. Now Python does one final crucial translation. It takes that logical AST and compiles it down into a set of really low-level instructions called bytecode. This is the native language of the Python virtual machine, the engine that actually runs your code.
Now check out this transformation. Our one simple line of Python has become 4 separate bytecode instructions. Here's how it works. The Python virtual machine, or PVM, uses this little temporary workspace called a stack. First, loadcons2 pushes the number 2 onto the stack. Then, loadcons3 pushes 3 right on top of it. Next, binary add pops the top 2 items off, the 3 and the 2, adds them together, and pushes the result 5 back onto the stack. And finally, store name x takes that 5 off the stack and stores it in the variable named x. This is what the interpreter is actually running.
So we've seen the whole journey. And yeah, it's fascinating from a computer science perspective, for sure. But why does this matter to you as a developer? Well, because understanding this pipeline, especially that AST stage, literally gives you superpowers.
I mean, think about it. What if you could intercept your code at the blueprint stage? With the AST, you can. You can actually get in there, analyze the blueprint, change it, add to it. You can essentially rewrite your code on the fly before it ever becomes bytecode. You become a real-time architect of your own code's logic.
A perfect real-world example is sandboxing. Imagine you're building a platform where users can submit their own Python code to be run.
That's kind of scary, right? They could try to import OS and delete all your files. But by walking through the AST, you can programmatically find and forbid dangerous operations before they ever have a chance to run. And this is basically how you do it. You can write a simple tool, an ast.node transformer, that walks through the code's blueprint. You tell it, hey, just visit every single import node you find. And if it finds one, it just raises an error, completely stopping the process cold. Just like that, you've created a secure sandbox where using import is physically impossible.
Another incredibly powerful use case is something called instrumentation. This is where you automatically inject new code and functionality into the existing AST. Think about adding detailed logging or performance monitoring or complex debugging, all without ever having to manually touch your original source files.
Take a look at this. We could create another transformer that hunts for every single assigned node in the blueprint. That's every time a variable gets a new value. And when it finds one, it dynamically creates and inserts a new print statement right before the original assignment. The result? Every variable assignment in your entire program is automatically logged, and you didn't have to write a single extra print statement yourself. How cool is that? So let's just do a quick flyby summary. Python's execution is not just simple interpretation, it is a sophisticated pipeline. Lexing breaks your code into tokens, into little Lego bricks. The AST builds a logical blueprint from those bricks. Then bytecode translates that blueprint into low-level instructions. And finally, the Python virtual machine comes along and executes those instructions. You know, understanding this process really moves you from being just a user of Python to being an architect. You now know that the code you write is just the beginning. You can access, you can analyze, and you could even change the very blueprint of your programs before they run. So the real question isn't just about how Python works. It's about what you're going to do with this new power. Now that you know you can rewrite reality, what will you build?